So we just proceed from where we were yesterday. We had designed the question. So we are just proceeding the same. Now there is a table that you are supposed to draw. That table looks like this. We call it the analysis table. We call it analysis table. In the analysis table, we always begin with current, sorry, not current. We start with new. We start with new. New reorder point. There's a small column. Then we bring safety stock. There's also a small column, just the units. Then we bring holding costs. It's a little bit wide kidogo, though not very wide. Then the widest is shortage costs. Hello, good morning. Hello, good morning. Hello, can you hear me?
Yes,
How are you?
I'm fine.
Karibu.
Asante.
So we have just begun. We are drawing the table for the question we had started yesterday. That is how the table looks like. So design that. Once you finish drawing, let me know. Just write finished. Anza kuchora, let me know. Yes, Patricia. Yes, Carol. Now, once you have drawn the beginning point is always the current reorder point. So the current reorder point is 850. So you put it here. When you put it there, it becomes the new reorder point. Now, there is a formula we wrote yesterday. Na tukasema new reorder point is equal to the current reorder point plus the safety stock. So if the current is also the new, what is the safety stock? Zero. Good. So this one is zero if you use that formula. So our holding costs will be 0 times 5,000. No. The holding cost was 1,000. So times 1,000. And that gives us a 0. We said yesterday that you can only be out of stock if demand during lead time is more than your reorder point. I want you to look at the question there where we are given demand during lead time and tell me whether you can see any demand that is more than 850. And if you can, tell me the first one from that table. Good. Carol, are you able to see it?
Yes.
Yes, okay. So 900. Now, you can only be out of stock if demand is more than 850. If 900 customers come and you have 850, how many customers will miss the units?
50.
Good. So that 50 is the shortage here. And the probability of demand being 900 is 0.05. Higher. We have another one that is greater than 850, which is 950. If you have 850 and 950 customers come, how many will miss?
100.
100. Good. So plus 100. And the probability of demand being 950 is 0.04. Patricia, if you have 1,000 customers coming and you have 850 units, how many customers will go home without? $150. Good. So inakaa tumeelewa hiyo concept now. So that is when we have 1,000. So the probability is 0.03. Higher. If we go to 1050, how many customers will miss?
200.
200. And the probability of 1050 is 0.03. And then if we have 1100, how many will miss? 250.
250.
And the probability of that happening is 0.02. So if you work out what is within those brackets, it shows you the number of units you expect to be out of stock. And the number of times that can happen is equal to the annual orders. And we had computed, or we had been told annual orders were 5. So the total of that you multiply by 5. And then every unit out of stock, it is going to cost you 5,000 shillings. So with that, give me the answer. $550,000. So in our formula, we said the total cost will be the holding plus the shortage. So that gives us 550,000. Higher. We now try the next one, 900. So if 900 becomes our new reorder point, and we know the current is 850, that means now we have a safety of how many units? 50. Good. And therefore, our holding cost will be 50 times 1,000, and that is 50,000. You can only now be out of stock. You can only now be out of stock if you happen to exceed 900. Now, the first one that is more than 900 is 950. So at 950, you will have a shortage of 50 units. And the probability of demand being 950 is 0.04. Higher. The next place you can be out of stock is when we go to 1,000. If demand is 1,000 and you have 900, you will report a shortage of 100. And the probability of demand being 1,000 is 0.03. Higher. The next one is 1050. If you go to a demand of 1050 and you have 900, then you'll have a shortage of 150. And the probability of that happening is 0.03. The last one is if you have a demand of 1100 and you have a new reorder point of 900, that will occasion a shortage of 200. And the probability of that happening is 0.02. Then all these you multiply by 5, then you multiply by 5,000. Good. 337,500. Now 337,500 ongeza hii 50,000. Ongeza 50,000 ndio tujue huko mwisho ni ngapi. $387,000. Haya, we now try 950. At 950, if our current reorder point is 850, that means we have a safety of 100. Actually, what you notice, hii column hapa ya safety inaanza kujipanga, ndio hii. Kujipanga hapa. So, this will be 100 times
387,500.
Oh, sawa, thank you. So this will be 100,000. This will be 100,000. So if it is 100,000, if you go beyond 950, the first point you stop is 1,000. That will occasion a shortage of 50. And at 1,000, the probability is 0.03. If you go beyond that, you stop at 1050, which will give you a shortage of 100. And the probability there is 0.03. If you go beyond that, you stop at 1100, where you report a shortage of 150. And the probability is 0.02. 0.02. Now, this one you multiply by 5. You multiply by 5,000. $187,500. So this is $287,500. Higher. The next point is 1,000. At 1,000, the safety now will be 150. So 150 times 1,000. This is 150,000. 150,000. So when we come here, we will have a shortage of 50 if we got 1050. And the probability of that is 0.03. Plus, if we go to 1100, we will have a shortage of 100. And the probability of that happening is 0.02. Then times 5 times 5,000. $87,500. So add 150,000 there. You get two. You get what? 237,500. The next stopping point. The next stopping point is 1050. 1050, now you talk of safety of 200. Haya, sasa ikiwa hivyo, it is 200 times 1,000. So this is 200,000. This is 200,000. With 200,000, at 1050, if you go now beyond that, is 1100, you report a shortage of 50. At the probability is 0.02. So we don't have any other beyond that. So times 5 times 5,000. $25,000. So this 25,000 you add to 200, you get to 25,000. You get to 25,000. The last point is at 1100. At 1100, you have a safety of 250. So this will be 250 times 1,000. And that gives us 250,000. So when you are there, the shortage is only 0 because you have the maximum. And the probability of happening, it can't happen. So the probability is 0. You multiply by 5, you multiply by 5,000, and this gives you 0. And therefore, the total here is 250,000. It's 250,000. Now, that brings us to the end of that table. When you get to the end of the table, you pick the lowest costs, the lowest cost of this. So the lowest cost of this is this one. It's that one. So at that, it means our safety is 200 and our new reorder point is 1050. So in your conclusion or in your summary, you are supposed to tell us three things. One, what is the new reorder point? New reorder point, we have found it is 1050 units. 1050 units. The next thing you should tell us is optimal safety stock. Optimal safety stock. So at that point, we have also clearly seen that the optimal safety stock is 200. And the last thing that you should tell us is the probability of stock out. Probability of stock out at that point. Now, if you stop at 1050, you can only be out of stock if demand exceeds that. And the only point it exceeds 1050 is 1100. At 1100, the probability is 0.02. Yeah, that's the only place it can exceed. So the probability of being out of stock at that point is 0.02. Kama tuko sawa at that point, sema yes. Good. Now, if you found this one to be the optimal, then the probability of being out of stock will be 0. Kama hii ya mwisho ndio imepatikana kuwa mzuri, the probability of being out of stock will be 0 because you don't have any other. If you found, for example, this 950 to be the optimal, the probability of being out of stock will be the probability of this 1000 plus the probability of 1050 plus the probability of 1100. If you found 950, the probability of being out of stock, it is the sum of the probabilities that are below that. I hope that point is clear. The question we have handled had given us demand during lead time that is exact. You are given demand that is exactly demand during lead time. There is another format of a question where what you are given, the demand that you are given, is more than demand during lead time. And maybe you can make this a side notes. If the demand you are given is greater than demand during lead time, you need to divide and bring it back. You need to divide. For example, if you are given demand for 10 days and lead time is 2 days, lazima uitoe kwa 10 days, urudishe to 2 days. The third possibility is demand that you are given in the question is less than demand during lead time. Now, if you are given less, what you need to do is to multiply. For example, you are given demand of 1 day and lead time is 3 days. So what you need to do, you must move it from 1 day to 3 days. So to cement that, I want us to handle a question here of December 2002. Of December 2002. Of December 2002. Question 2. So let's go there. You see it, read. When you see it, December 2002, question 2. I'm saying when you see it, read, because I need to open my past papers also. And as read, I'll be looking for another one.
A company has determined that the EOQ for its only raw materials is 2,000 units every 30 days. The company knows with certainty that a 4-day lead time is required for ordering. The following is the probability distribution of estimated usage of the raw material for the month of December 2022. Usage units probability. Stockouts will cost the company 100 shillings per unit, and the average monthly holding cost will be 10 shillings per unit. Require determine the optimal safety stock. 2. Compute the probability of being out of stock.
Thank you. Thank you very much, Patricia, for reading for us. Now, the procedure begins, as we said yesterday, that you must identify 5 things. You must identify 5 things. Now, in seeking to identify our 5 things, number 1, we said you get unit or annual unit holding costs. That is the first thing. When you look at this question, what you can see is stock out will cost the company 100 shillings per unit, and the average monthly holding cost is 10. So the holding cost that is given there is 10 per month. And remember telling you that you must be very attentive to the measures of time that are being used. So here the measure of time is annual. But the examiner amekupea per month. So you must make it to be annual. So making it to be annual, we know that 1 year has 12 months. So you convert it to 120. You must make it that way. Number 2, you must get unit shortage costs. The shortage cost per unit. Shortage cost per unit, that one we are given straight, it is 100. Number 3, you must get annual number of orders. Annual number of orders. Now, annual number of orders, we are not given straight, like we had in the first question. We are not given. Now, if we are not given, the first place you run to is the formula that you know of how to get annual orders. We know that N is usually given as R out of Q. We know that. Now, for us to use that formula, we must get to know the annual demand, which we are not given. Although we can get it, because now we are told demand per month. So we just multiply, and that will give us the whole year demand. But now, computing Q, the other items that we require, one of them is the fixed cost per order, S, which is not here. So that tells you that formula cannot work. So what will work for you is the knowledge of the meaning of the word EOQ. EOQ tulisema is the number of units you order at a time. At a time, at the most economical cost. So if you are told you are ordering every 30 days, that means every 30 days you are ordering how many times?
Thirty times.
I'm saying you are told order every 30 days. Now, in 30 days, you will make how many orders?
One order.
Good. One order. Now, 30 days are also known as what? In terms of measurement of time.
One month.
Good. 1 month. Now, we know that we are looking for the whole year. And therefore, 1 year has how many months?
12.
So we will have made orders how many times?
12 times.
Good. That's how we go about it. So this one now, we will say it is every 30 days, and that gives us 12 times. Yeah, so that is how you establish it. So that brings to us 3 ways of getting that. The first way, umepewa tu direct na swali, kama hiyo swali yenye tumemalizia. The second way, utumie formula, if it can work. The third way, utumie definition. But now, formula should be the last one. Formula should be the last one. Kama you are given, unatumia hiyo. Kama the definition helps you, unaenda na hiyo. Kama sasa you are not given and this one is not helping, sasa hapo ndio unapambana na formula, you get the annual number of orders. Haya. After that, you get the current reorder point. The current reorder point. Now, current reorder point, unaangalia kama umepewa. So this question has not given us. So if it has not given us, we run to the formula. I don't know whether it's Cara or Patricia who was asking me about the formula that we had written some times back, daily usage. Can you remember it? Times read time. Yeah, daily usage times read time. That's the formula. So we must now be able to use this. what we are told up there is that the company is using 2,000 units every 30 days. So per day, that is what they are using. And I remember last time emphasizing that the unit of measurement of time that you use, it is guided by how lead time has been expressed. So kama lead time umeambiwa in terms of days, then you use daily demand. Kama umeambiwa in terms of weeks, you use weekly demand. Kama umeambiwa in terms of months, you use monthly demand. Sasa ukiangalia hii swali yetu inasema we have a lead time of 4 days. 4 days. So the unit of measuring time that has been used is days. So now I will get the daily demand, then I multiply by 4. So work out that and give me the answer. So we can round appropriately. So that would be 267 units. All right. The next now is the probability distribution. Probability distribution. Now, in the probability distribution, we normally have 2 columns. We have demand during lead time. And then in nitaacha space because it will have a working. And then the probability. And then the probability. So sasa, when you look at this question, we are told the following is the probability distribution of estimated usage of the raw material for the month of December. So when you are given these units for the month of December, ni kumaanisha it is the demand for how many days? It is the demand for how many days? 30. Good. 30. So, and our lead time, you can see our lead time is 4. And what we require is demand during that for those 4 days. So lazima uitoe kwa 30, urudishe 4. That's what I had said. You are given more. Demand is more. So lazima urudishe. So how tutarudisha? Utachukua hii ya kwanza 1800. You divide by 30. The answer you multiply by 4. That's how we return it. When you multiply by 4, you're getting 15. Okay, 240. And the probability of that happening, that one we are already given, 0.06. So we go to the next one, which is 1900. You divide by 30. You now take it back to 4 days. Unapata per day, then unaitengeneza ikue
You said when the demand given is greater than the demand during the lead time, you divide.
Yes.
So our demand given here is 1,800,
It is?
which is greater
Mhm.
than the 4.
Uh-huh.
So we are supposed to divide or multiply.
We divide. So now we divide.
And then we multiply by 4.
Then we multiply. Maybe what you could add to what I had written, you could add like this. I said you divide, then now unaweza ongeza, you now multiply. Na ile nilisema you multiply. Now that one you may not need to divide. And even this one, si kila mahali uta multiply, because you could be given the lead time is 1 day. But what I wanted to get is the starting point. The starting point, kama umepewa more, you must start by dividing. You bring it down. Then sasa una express in terms of the lead time. Is that okay?
Yes, it's okay. So the one for 1900, it's 253.33.
So you can make it 253. So the probability is 0.14. We go to 2000. We divide. Then we multiply by 4. This is the one we had there, 267. And the probability is 0.3. The next one is 2100. Divide by 30. Multiply by 4. To 80. And the probability of that happening is 0.16. So nataka uendelee namna hiyo, umalize mpaka kwa 2500. Ukimaliza uniambie finished. Maliza niambie finished. Winnie, good morning.
Morning.
Good. Karibu sana.
Asante.
Okay, so if we are finished, then that's good. I was looking for the question I had told you, but I'm not getting it. So we said our analysis table. We have the new reorder point. The new reorder point. Then we have the safety stock. Then we have the holding cost. Then we have the shortage costs. So shortage, you click it there. Then we have the total cost. Total costs. Maliza kuchora hiyo, sema yes. Ukimaliza kudesign hiyo table, sema yes. Winnie. Okay, so if we have finished, then the first thing I told you, we always begin at the current reorder point. So our current reorder point is 267. Our current reorder point, as per the formula we have computed, is 267. At that point, we have said no safety. So the holding cost will be 0 times 120. So that will be 0. Now, after 267, the next DDLT is what?
$293, $280, $280.
280. Now, if it goes to 280 and you have 267, that will create a shortage of how many?
13.
13, good. So, 13. And the probability of demand being at 280, the probability of demand being at 280 is 0.16. Higher. After 280, we go now to 290. $293. So if you go to 293 and you have 267, that gives you a shortage of
26.
26. The probability of demand being 293 is 0.13. After 293, what next did you get?
307.
307. I'm just taking note here so that I'll be able to refer there. So if demand is 307, now we have 40 as a shortage. And the probability of that happening is 0.1. After 307, you went to
320.
so 320. So at 320, you will have a shortage of 53. And the probability of that happening is 0.0.
0.07.
After 320, you went to
333.
333. So at 333, you have a shortage of 66. And the probability of that happening is 0.04. So ukifungia hizo, that will give you the number of units expected to be out of stock. Now you multiply this by the number of times that can happen. We found 12. And the shortage cost, we know per unit it was 100. So with that now we'll be able to know what is the expected shortage costs. $18,972. Is it confirmed? It's confirmed. Winnie and Patricia, are you confirming that figure? We move. Keep quiet, then I have to move. So after 267, the next possibility is 280. So at 280, we have a safety of how many units? Tell me, we have a safety of how many units? At
13.
13. So our holding cost will be 13 times 120. That gives us what?
1560.
1560. You can only now be out of stock if you happen to go beyond that. And the first point you stop is at 293. So if you have 280 and 293 customers come, you report a shortage of
13.
13. And the probability of happening is 0.13. Plus, the next point is 307. So if you are holding 280 and 307 customers come, you report a shortage of
27.
27 with a probability of 0.1. Plus, if you go to 320 and you have 280, that gives you a a shortage of
40.
40. And the probability of that happening is 0.07. If you go finally to 333, that creates a shortage of
53.
53. And the probability of that happening is 0.04. Now that one you multiply by 12, then you multiply by 100. Yes, we need. We need, you can ask.
I was asking which sitting. I've joined late.
The question is December 2002, question 2. December 2002, question 2. Now give me that cost there. Cost shortages. $11,172. Someone else to confirm? Yeah, if it's confirmed, that's good. So now add to this one. Add 1560 there. Oh, when you add, it gives us 12,732. 12,732. Oh, here I should have brought this one, 18,972. The next point is at 293. So if you have 293 as your new reorder point, and the current reorder point is 267, that gives you a safety of how many units? A safety of 26. And I told you this column ndio hii inaanza kujipanga hapa. So it is 26 times 120. 26 times 120. That 120. Now, if you are holding 293, and demand now goes to 307. Demand goes to 307. You will have a shortage of how many? You will have a shortage of how many? 44. Huh? Karo, pana. 14. Because we are at 293. And now the first point is 307. So it's 307 minus 293. Good. 14. So 14, the probability of demand being at 307 is 0.1. Haya, ukienda kwa 320, that will give you a shortage of a shortage of 27. And the probability is 0.07. Haya, ukienda kwa 333, that will give you a shortage of 40. And the probability is 0.04. Now this can happen 12 times and then 1100 per unit. No, just 100. 100 per unit. So 89, 89.
No, it's 89, 88. Just typing error. 89, 88.
89, 88. Good. So if it is confirmed, we'll proceed. One is confirming. Tricia is talking of 58, 68. Even Carol. So we need, maybe you check yours. 58, 68. Okay, good. 58, 68. That's why it's important to confirm. 58, 68. So 58, 68, you add that 120. Inakupea ngapi? Or 89, 88. Oh, we knew you had given me the final one. 89, 88. Haya, so hiyo tunafunga. Shafunga hiyo. We go now to 320. Haya, sasa nataka utembee peke yako kwa 320 na 333. Maliza the two of them, tell me finish.
What about 307?
Oh, kuna 3, oh, okay. Kwa nimeona kama So utembee kwa 307, utembee kwa 320 na utembee 333. Ukimaliza uniambie so that we compare the answers. Maliza uniambie. Kama umekwama useme. Isikuwe na ngoja ati unamaliza na unaona giza. There's Patricia. Carol. Good. Winnie? So Carol tells us that at 307, total cost is 62.76. The next level, we have 69.84. And the last one, we have 79.20. So, Patricia and Winnie, are you confirming those values or disputing?
The last two are the same. The first one, 307, mine comes to 71.40.
71.14.
71.40.
71.40. So, who else? Winnie. So nani Patricia, nisomee hapa safety stock ulipata 40 eh?
40, yes.
So this is 40 times 120 ukapata 4,800 eh?
Yes.
So at 307 the shortage is if you go to 320 the shortage is what?
13.
13. And the probability of that is 0.07. Then at 333 the shortage is what?
26.
26, and the probability is 0.04 times 12 times 100. Sasa hapa ndio unasema umepata so Carol, you also agree it is
Yes.
71.40. So nisomee hii uko na ngapi hapa?
23.40.
23.40. So that now this one is 71.40. Higher. Are we agreeing with the others too? Are we agreeing with the others too? Okay, so if we are agreeing, then that is fine. And the smallest then would be this one. This one. So this one is giving us a safety of 66. Ndio. a safety of 66. So if it's giving us a safety of 66, in our conclusion, I've told you you should give us 3 things. 1, new reorder point. So our new reorder point is then 320 units. You should give us optimal safety stock. Optimal safety stock is now 66 units. And probability of shortages. Probability of stock out or shortages. Probability of shortages is also the probability of stock out. So it is only this one. So that is 0.04. And it's only a coincidence, the 2 questions we have solved together, zimeonyesha ya mwisho ikiwa the one that has the probability of stock out. So don't cram that kwa kila swali itakuanga hivyo. No. I say,
Excuse,
yes, Carol.
I thought optimal safety stock should be that one for at 53.
This one. No, here. This is 53.
Yes.
At 320, it is 53. Eh? Oh,
Yes.
sawa. That's how it should be. 53. So hapa ndio kuna 66.
Yes.
Okay, good. Good. So the optimal safety stock, because tunachukua hii line yote, the one with the lowest costs hapa. So nafikiria hiyo habari ni mzuri. Ama hakuna swali. I was really looking for a question. I know it is somewhere. Sija manage kuiona. Maybe utaiona tu baadaye. I know maybe we'll be finding it. Hiyo swali nayo imepeana daily demand. Lakini unaambiwa lead time is 5 days. Lead time is 5 days. Sasa what happens there is that daily demand na multiply by 5 ndio ikuwe demand during lead time. Nikipata baadaye nitawaambia. But for now, your assignments are August 2023, question 5A. And then August 2022. August 2022, question 4B. Those are the assignments that I would like you to attempt. To cement that understanding. We still have half an hour left. So we proceed to something else. So what we did yesterday, or we began, tulisema when you experience changes in demand and lead time, the approach you take will either be use of permitted shortages or use of safety stock. When we came to safety stock, we said the question is, what is the optimal safety stock? Na ndio hiyo tumekuwa tukijibu hapo. Na hiyo tumekuwa tukijibu because we knew the shortage cost. But there is also an instance where shortage cost is unknown. So let's look at unknown shortage costs. Unknown shortage costs. What happens if the shortage cost is unknown? Now, there are instances where it is very, very difficult to know the shortage costs. For example, in a hospital, if a particular drug is out of stock and we lose a patient, so what is the cost of that drug? The cost of that drug being out of stock is the cost of that life that has been lost. So what is the cost of a life lost? That one we cannot quantify. Another example is a building. You don't have a fire extinguisher and fire breaks. So the whole building is lost. The business is burnt down. So what is the cost of that fire extinguisher being out of stock? It is the cost of that building and the business that has been lost. So the building we can be able to estimate. Hii nyumba yetu tulikuwa tumejenga na hii pesa imeisha. That one you can estimate. But what about the business that was there? How do you value business? And you know from your FM, there are many methods of valuing a business. And some of them we never even agree. And you not only value that business, but what about the people that were working there? What is the loss to them? Not only the people that were directly employed by that business, we also have some other people in the neighborhood that were depending on that business. So ukianza kufikiria hivyo, it becomes impossible to get to know the cost. So what do businesses do? They, or even in a class like this one, let me also calm down to a class like this one. If I keep on missing classes, my customer, who happens to be you, may be disappointed. Now, that customer, when they become disappointed, they can vow that anyone they come across and they hear them asking about CPA, they will never recommend them to me. And if they hear anyone talking about Kimani, wanamwambia usiende hapo, usiende hapo. So for how long will this person keep on discouraging students from coming to me? I can't know. For how long will this person fail to recommend students to me? And how many do I know that this person would have recommended? Now I'm losing all that because I created shortages. Yeah. So when you look at it that way, you can then appreciate that the cost of shortage can be so big. So what businesses do, they establish what we call service level. Now, a service level is what nowadays you hear many companies call the service charter. It is where you agree or you say that we desire to meet our clients' demands, maybe at 95%. Some companies even go to an extent of giving the time frames that when you come here, they state the services they offer. I've seen it like in hospitals. When you visit the doctor's room, they should take this. When you do this, they should take this. So within like a day or within like 5 hours, all this should have been done. Even in banks, I see those service charters. So you establish a service level. Service level is the proportion of time that you seek to meet the demand of your customers without any delay. Even a person like me, I can come up with one and I say, if I'm teaching you 3 lessons in a week, I desire that in every lesson, I will be starting exactly on time. Na nikichelewa sana, only 5 minutes. So I can even write it and communicate to you that anytime there is my lesson, the maximum time I desire to be late is 5 minutes. That's what we call the service level. Then the opposite of that, or the reverse of that, is called risk level. Risk level is the probability that you can experience delay in serving your customer. If I'm supposed to start this class at 5, what is the probability that I will delay and start at 5:30? What is the probability that I will even miss the class? That's called the risk level. Now, service level plus risk level, they give us 1. And how you get the service level, it is looking at the demand, the total demand, and you check how many units did you supply without delay over the total demand. Like for myself now in this week, I can say I have had 3 lessons with you. So how many did I start on time? So if I started all the 3 on time, I supplied without delay, the total demand was 3. So my service level was 100%. So risk level 0. But if I only did 1, it is only 1 lesson that I started on time, then my service level is 1/3. I hope that is understood. So we have 2 methods that are used to handle this. One is called linear interpolation. So linear interpolation works with the similarities and congruency of figures. It argues that if you know some figures, you can know the others. The other one is called normal probability distribution, and I believe that these things are presented well in your notes. So I will not redo them here, but I will redo when we are answering a question. So having done that, in your handout, do we have a question 1? If you are looking at your handout, let me confirm whether it's there. Is it there? Okay. If it is there, this is what you are going to do. So the question says, determine the optimal reorder level for a company whose demand service level is 84% and demand during lead time has the following probability distribution. So we are given that. Okay. So in solving that, so you just say illustration 1. Illustration 1. So we are using linear interpolation method. Linear interpolation method. Linear interpolation method. So in using linear interpolation method, you need to get the demand during lead time. Demand during lead time. Then you get what we call the specific probability. Specific probability or the marginal probability. Then you get what we call less than cumulative probability. Less than cumulative probability. Less than cumulative probability. So the demand during the time is 10, 15, 20, 25, and 30. And then the specific probabilities are 0.1, 0.2, 0.3. 0.1, 0.2, 0.3, another 0.3, and 0.1. And 0.1. And 0.1. Haya, sasa less than cumulative probabilities, you just add kawaida. This, you start here, you add this, you get 0.3. You add this, you get 0.6. You add this, 0.9. You add here, you get 1. Yeah, that's what we call the less than. Less than. We'll be having another one called more than in another area. Now, the survey's level here is 84%. So 84 is between here. This is 60 and this is 90. So 84 should be somewhere here. That is where we have 84. So if that is where we have 84, then what you do, you seek to draw a triangle, like a diagram like this. Nachora tu namna hii, just like a small diagram. This is y-axis, and this is x-axis. That's like a small one, but not too small. Then you mark these 2 points. The first one here is 0.6. The next one here is 0.9. Then 84 would be somewhere here. 84 could be somewhere there at the middle. Remember, we are estimating. Then 60 is corresponding to 20. So you come and put 20 there. And 90 is corresponding to 25. So these are units here. When you do that, you now seek to plot. So here 60 and 20, this one, you can call it point A. This one, 25 and 90, here, you can call it B. Then you connect them like this, using a straight line, that way. Alafu sasa unachora hivi, hii inakuja namna hii.
Napata wapi?
Napata hapa. Napata karibu na hiki. Napata hapa karibu na hiki.
Enda mimi acha kutafuta ile penye aliosha.
Haya. So this one is point C. So what is the name of that figure? Yeah, it's a triangle. Good. Now, you now estimate. Sasa hii 84 unaichorea an incomplete line hivyo. Maybe hii point inakuja, we call it point D. Alafu sasa unateremsha ingine hapa. Hapa you call it E, and this number of units you call them X. So we have 2 triangles there. Ukishachora hivyo, down there unasema triangle ABC is similar to triangle ADE. Yeah, it's similar. It's only size. It's only size. And thus, and thus, and thus, so we say thus, if we get the sides that are known, this BC, you divide by this other one, the corresponding DE. The answer you get should be equal to, uchukue hii side, AC. The bigger triangle inakuwa kwa numerator. You divide by this one, AE, that is known. Hiyo ndio inaitwa the principle of similarities and congruency. In mathematics, in Form 1, this is called translation factors. So BC ni hii 0.9 to 0.6. Hii kaga ndio hapa mpaka hapa. Then hii DE, D ni kutoka 84 mpaka 60. That way. Should be equal to AC. AC ni hii kutoka hapa 25 mpaka 20. So 25 to 20. And this other one, it is X to 20. X to 20. So this one you can see is 0.3. This is 0.24. This is 5. And this is X. So when you start solving, this becomes 0.3. X minus 20. 5 times 0.24. So tunasonga tu, tunasema X minus 20 is equal to 5 times 0.24. You divide by 0.3. So kutoka hapo jipange uniambie X is what? X is 24. X is 24 units. Now that 24, or those 24, that now becomes our new reorder point. That is your new reorder point. Yeah. So this method does not help us to know the safety stock, but it helps us to know the new reorder point. The new reorder level. So jika kuna swali? If we are okay with that,
Mwalimu, mbona mimi napata 2.4, X to be 2.4?
kuna mahali unafanya makosa. It can't be 2.4. There must be something greater than 20. So now I go between 20 and 25. There must be. So just rework out again. Sema 5 times 0.24. You divide by 0.3. Then you add 20. With the
It's 20.
eh?
Wow.
Iko sawa?
24 iko sawa.
Good. Yeah. So I was saying that you can attempt the question that is given there, number 2, in the handout. I hope I've given you 2. Do you have the second one in the handout? Hmm? Do you have the second illustration? Second question. If it is not there, then you attempt November 2016, question 2A. November 2016, question 2A. Utumie tu hii method, linear interpolation. So when we meet next, God willing, we shall solve the same question, this one, using normal probability distribution. Using normal probability distribution. So we stop there for today. Let's meet now in our next lesson. Thank you.